Hello everyone, today we are going to be taking a look at the Tubular Quad version 5. This is a FPV freestyle frame that I designed and built from scratch, and like the name implies, this quad uses tubular arms, and it is the 5th iteration of this quad, and it comes at a kind of special time for me because this marks the 3-year anniversary since I built the very first version of this quad. And the design has come a really long way through a lot of designing, building, testing, crashing, breaking, and repeating that whole cycle. So in this video, we're going to be taking a look at the design philosophy of this quad, its design features, and how it compares to the previous version. And then we'll take a look at some of the manufacturing tricks that I used to manufacture this without a CNC. And then I will let you guys know how to get the free plans for this frame. But first, let's see how it's built. Okay, so I hope that you guys enjoyed that build montage. For your reference, this quad on the left is the previous version, the version 4, and then this frame on the right is the version 5, and we'll be drawing some comparisons later. So first, let's talk about the design philosophy behind the tubular quad. So the original reason why I built the first tubular quad was because I could not find a commercially available frame that met all of the criteria I had at the time. And that criteria was I wanted a 6-inch freestyle frame that was a true X and had space between all of the props and was lightweight. So let's dissect why I wanted that. So I wanted a 6-inch frame just because I personally prefer how 6-inch flies. I wanted space between all the props because that gives the individual props kind of room to breathe, and it helps prevent the turbulence coming off one prop from interfering with all the other props. And I wanted a true X because flying freestyle, you know, you could be going sideways, backwards, whatever. And I personally want the quad to feel the same no matter which direction it's going or which direction I'm flipping. And, you know, the true X is symmetrical, and I want the quad to basically behave symmetrically. Now, on top of all that, when I was designing the tubular quad, I wanted a really tight center of gravity. So I achieved that by going with a really short fuselage and then putting the battery on sideways toilet tank style. So what this does is it has all of the mass in a really tight ball in the center of the quad, and this reduces the moment of inertia of the quad, and therefore it's really easy for the motors to accelerate and decelerate the quad rotationally when you're doing tricks or whatever, and it just gives the quad a better control feel and better response. So that's basically the general layout of the tubular quad, but now let's talk about why I use tubes and not flat carbon plate, because you've probably noticed that the vast majority of frames that you can buy use flat carbon plate. And I think the reason for that is it's just really easy to put a big sheet of carbon plate in a CNC machine and cut out a bajillion frames and sell them. Whereas when you have tubes, you have to machine them individually or whatever, and the big thing is getting a flat place to mount the motor that's not going to break off or whatever, and I think that's really the biggest hurdle. But tubes themselves as arms and as structural components really have a lot of advantages to just a hunk of material, which is what carbon plate is. So first of all, a circular profile moving through the air has approximately half the coefficient of drag as a square or rectangular profile moving through the air. So tubes are more efficient in terms of drag. To me, the big advantage to tubes is that they have a higher cross-sectional moment of inertia. So basically, the material is distributed away from the center of this cross-section of this shape, if you look at it dead on like this. And what that does is it gives the arms a higher bending strength. So you can utilize this in one of two ways. Either you can benefit from the extra strength, or you can remove material and have the same strength but at a lighter weight. And another benefit of this higher moment of inertia of a tube is that it's not only stronger, but it's stiffer. And that is really important when it comes to vibrations and tuning issues. So the stiffer your frame is, the higher the natural frequency it wants to vibrate at is, and the flight controller has a much easier time filtering out higher frequency vibrations than lower frequency vibrations. So you want the frame to be as stiff as possible, and you can help that by using tubular arms for their higher stiffness. So tube arms are stronger, or they can be lighter, they're more aerodynamic, and they're stiffer. So there's really a ton of advantages, but you have to get over those manufacturing hurdles and figuring out how to mount the motors. So now let's go ahead and talk about the design more specifically, and also take a look at what has changed for the version 5 compared to the version 4. So the arm design and the motor mount design and the arm mounting design is exactly identical to the tubular quad version 4. So I'll do a brief recap of that. The tubes themselves are 12 millimeter outer diameter, 10 millimeter inner diameter, all the way up until about here, at which point there is a smaller tube epoxied inside this outer tube, and that doubles the wall thickness from 1 millimeter up to 2 millimeters. So what that gives you is 4 millimeters of screw engagement basically with the arm. And the reason why I made it thicker here is the screw holes add a lot of stress concentrations, and when you crash into something or you hit the end of the arm, whatever, this acts kind of as a big lever, and it creates just a lot of stress in this area where the arms mount. So there's just more material here to deal with the higher stresses that this part of the arm takes. Now, I haven't had any durability issues with this design of arm, even though it is only 1 millimeter thick for basically the entire length. Haven't broken any tubes like this. The only disadvantage is that you basically have to run arm bumpers, and I didn't really run arm bumpers for the version 4, so you can see what happens to the ends of the arms. They just get chewed up a lot faster than, say, a carbon plate arm would, just because there's not very much material there. But because it's a tube and not just a hunk of material, the strength and stiffness is still pretty good. So, you know, I didn't have any durability issues with this design. The motor mounts are 2 millimeter carbon plate, as is everything else. And that way you can cut out all of the parts from the same piece of carbon. And these are secured by first being epoxied onto the arm, and then they are wrapped with carbon tow, which is then soaked in epoxy resin. And that makes it so these things do not go anywhere. Once again, no durability issues with that on the version 4 or the previous version, which also had the same style of motor mounts. And the arms are mounted using the stack screws as the inner mounting hole. And I know a lot of people don't like using the stack screws to mount the arms, but to me, I basically never change arms or stack components, so to me it makes a lot of sense to have these screws serve double duty and save some weight in the process instead of adding another 4 screws. And the weight penalty on the tubular quad would be a lot higher because these screws have to be extra long. And this whole arm mounting mechanism was the big change for the version 4, and it really has had a lot of advantages. So the version 3 looked like this. So the second set of screws was actually in the middle here instead of outside of the stack screws, and that just kind of multiplied the force at the end of the arms more, and there wasn't really enough space to get these screws far enough apart to reduce the couple moment, and there was basically no room to get the wires through to route to the stack, and that was all solved in the version 4 with this style of mounting where the second set of screws are outside of the stack screws, and then the arms don't touch at all, and that leaves a ton of room to get the wires through and solder them to the 4-in-1 ESC. So I am really pleased with how that system has worked on the version 4, so nothing has changed really so far about anything I've talked about. Now let's talk about the changes. So on the version 4, the failure that led me to design the version 5 is that the bottom plate failed right here and here. And you can see I've attempted to fix this to get a little more life out of the quad, but it hasn't worked too well. Basically, with this new design, I had these really tight radii here, 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 here as fillets. So that caused big stress concentrations in these areas, and just that's why it failed right here. I'm not too surprised about that. So on the version 5, first of all, I've widened the carbon a little bit here and here, and all of the fillets are slightly larger. They're now 2 millimeters instead of 1.5 millimeters to help reduce the stress concentrations. But the big change is that we've added a 5th standoff, but not a 6th standoff. So one extra standoff right here to help take some load off of this part of the frame and really all of the standoffs, because having 4 standoffs support a big GoPro and a battery is kind of a lot to ask. And another issue that arose from that is that the top plate could actually deflect in a crash and hit the stack screws, which, you know, didn't hurt anything, but it also wasn't ideal. So the 5th standoff should solve that problem as well. Now there's a couple of tweaks to the top plate as well. These 2 cutouts towards the back used to be a little bit smaller, but I widened them out because the battery strap holes used to be wider than these cutouts, which means that the top plate would have just failed here and here first, before failing anywhere near the cutouts. So basically there was an excess of material around the cutouts that really wasn't helping anything. So I saved a little bit of weight by widening out these two cutouts. However, I did not widen out the cutout at the front because there's a lot of stresses going on at the front of the quad because usually you crash flying forward. So I wanted to leave all that carbon there to help with the durability. So that's really all of the changes from the version 4 to the version 5. And the weight, despite the extra standoff, is still very good, I think. The version 4 with all the hardware, including the motor screws, came in at 99.8 grams, which I was super happy with because it was sub 100 grams. The version 5 is just slightly heavier at 102.7 grams, including all the hardware and the motor screws, which is still really good, and I think it's worth the 3 grams or so for what I think is going to be a lot more durable of a fuselage. So to give you just a little bit of comparison, the Hyperlite Glide 6-inch, which is my backup quad, and I think it's an excellent design, and it's a very light frame as well, that weighs 114 grams with all the hardware and motor screws. So this design is significantly lighter than some of the lightest frames out there, and I'm really happy with that. So now let's talk about some of the manufacturing techniques that I use to help avoid needing to use a CNC machine to manufacture this frame at home. So the first thing I did is I made a drawing at 1:1 scale with all of the carbon plate components on it. So that way I can print it out, I put it on the carbon plate, and then that just marks where everything has to go. So you're basically utilizing the precision of your printer to get all the hole locations and everything dead on. The other thing that I did was I utilized my 3D printer to make this arm jig to get the screw holes absolutely perfect on the arms, because drilling into round tubes is really hard. So I actually had a problem with the version 4's jig because it was dimensioned a little bit incorrectly. So when you clamped it onto the arm, this would warp and then it wouldn't sit on the drill press table quite right. So that actually led the holes on the version 4 arms to be a little bit off. But this time I got the dimensions fixed, and I also made it a little bit wider so that it can sit nice and flat on the drill press table, and everything lined up first try, no issues. So I was really happy about that. So if you were to build this quad, there are some tools that I would say are definitely necessary. First of all is a drill press. I really don't think you could get the hole locations precise enough with just a normal hand drill. So I would say a drill press is definitely a must. I also would say a Dremel is a must just for cutting out all of the carbon bits. And a disc sander is nice, but I wouldn't say you need it because you could just use sandpaper. And the other must would be a 3D printer so that you can print out this jig, because the jig is definitely a must for getting those arm holes exactly where they need to be. And of course there are some smaller things you'll need, like files, epoxy resin, drill bits, all that good stuff. But a drill press, a Dremel, and a 3D printer are the main things that I would say are a must-have. So if you are interested in building the Tubular Quad version 5 and you want the free plans, go to my YouTube channel, go to the About page, and then go down to For Business Inquiries, and you can find my email address there. Send me an email asking for the files. I will send you a zip folder with all of the original Inventor models, step models, and then STL parts for the 3D printed stuff, and then also the drawing files with all the carbon plates, including a PDF version if you don't have any CAD software to open those drawings with. Okay, that's it for this one. I hope you guys enjoyed the video. In the next video, we will be doing the electronics installation on the Tubular Quad version 5, and I will be talking about why I use the electronics that I use. So if you enjoyed this video, please make sure to give it a like. Let me know down in the comments below what you think of the Tubular Quad version 5, and if you have any ideas for how it could be improved in the next version. And 84% of you guys watching this are not subscribed, so if you enjoy the content and you want to help support the channel, please make sure you get subscribed. Also, I have a new Instagram page, timmy.r.c, so if you want to see little knickknacks and things that you won't be able to see on YouTube, please make sure to give that a follow as well. Thanks for watching.